Hi, so I will be talking about my 8.2D. So today I will talk about the algorithm which I made that computes the number of ways to form a given sum using coins that are the powers of two. So each of these are usable up to twice. I will explain the logic of the recursive code and why we have a base case, why we separate the logic into odd and even, why I wrote it that way. And after that, I will run the code and then I'll walk through an example of an algorithm, the algorithm that gives us a solution. I'll I'll give an example of how this algorithm works also, and I will show a recursive diagram showing the algorithm and example, right? So it's just kind of connected all together. So let me just start. So basically, um, if we look here, right here, this is basically the base case. So if the solve, right? So if the sum is zero, we return one because there's exactly one way to make a zero sum, which is by using no points at all. If the sum is negative, we return zero because it's pretty much impossible to form a negative sum using negative points, right? Right here. The comments will help speed this through. And then we have the base case result. So we return the base case result. So we call it from here, right? So best case result is basically returns one if the sum is zero and zero if the sum is negative. Get to the next one. This part. Specifically this part for the even and odd. So basically, this is my recursive logic. So we separate the case based on whether the sum is odd or even. This separate this base I just separate it so it's just easier to read. It simplifies the problem. And for even sum, we can break them into smaller parts. For odd sum, we reduce them by one to make them even. So this allows us to use the even logic, right? So I will show the even logic. Yeah. This is basically just computes for even sums, right? By calculating this. The next one is the odd one. This is just computes for odd sums, right? By this is the formula, right? So for even sum, it'll be over two. For odd, it'll be minus one over two, right? So I will show that formula and logic a bit later. So I think we talk about odd sum, right? Yeah. So we just talk about odd sum and then we just cache the result, right? To avoid any redundant calculations, we just get the straight calculation. Okay, let me explain you the logic of the recursive code. So the reason I made the base case like this, so I'll go to the base case right here. So basically, when the sum is zero, the function returns one. This is because there's exactly one way to make the sum of zero by using the points at all. This is basically representing empty set, right? Which is a valid combination. Now let's go to negative sum. So basically, it's the same thing. So because it's just different logic, right? So both logics apply to this. So negative sum was also apply to this. When the sum is negative, the function returns zero. So it's basically impossible to form a negative sum with non-negative points. So there is basically zero ways to achieve a negative sum. And the reason I separate it into two different logics instead of like just putting it all together, I think it was just easier. Um, I think it was just easier to read, easy to understand. So, like we talked before, so for even sum, right here, I split into smaller parts. So for like example, for sum to n, we can break it down with n and n minus 1, right? You can see right here. And the reason I did that is that it just simplifies the recursive structure. It just helps utilize like any previous computed results, right, through memorization. And then for the odd sum, we just convert them to an even sum by subtracting 1, right? We make it easier to handle with the even sum logic. And for sum to n plus 1, we reduce it to n. So this basically allows us to reuse even sum logic and make sure that our recursive calls basically converges in the end for the base case. Let me run the code, explain everything. Just let me run the code. So you can see all the tests passed. So my logic is correct. So let me go through an example, right, of me solving it using the same logic as this whole code. So I did this on my iPad. Excuse, like it's kind of messy, but so we start with solving 5, right? That's not my pick. I just picked 5 because I just felt it was a little easier, right? It wasn't a lot of stuff. So we check if 5 is neither 0 or negative, of course. And the result for 5 is not cached, right? Because this is the first call, so it's fine. Just go forward. So we know 5 is odd. So I put it right there as odd, right? So we use the odd logic. So our odd logic was right here. So we put 5 over 2 minus 1, and that'll be equal to 2. Now, after that, we do the recursive call, right? So we solve for 2. It goes here like this. So it'll be 2, but because 2 is even, we have to use the logic. So it'll be 2 over 2 equals to 1, 2 over 2 minus 1. So we use the even logic this time, right? So that'll equal to 1 and 0. So now, same thing we did at the top from here, we do it here. So we solve 1. I solve 1 first, right? And basically 1 is odd, so we only use the odd formula that we use up here. So it'll be 1 over 2 minus 1 equals to 0, and 0 is 0, 0, right? So we return 1 as the base case result. So in the end, we just combine all the results, right? So we combine the results, it'll be for solve 1, like we did here. Yeah, it'll be just solve 1 here, solve 0 returns 1, which is the base case that we saw. And so solve 1 returns 1. Solve 2, right? It'll be solve 1, right? So right here. Solve 1 returns 1, yep. So from here, so it just connects it together. Solve 0 returns 1, right? Like we did before down there. So it'll be, so solve 2, the result will be 1 plus 1 because both of them returns 1, right? So it'll be 2. So solve 2 equal to 2. And solve 5, right? Solve 5 is up here, right? So it'll be returns 2. And then because it's 2, it just returns 2, right? It's not like 0 or 1 or anything like that. So that's a logic. Let me bring up a diagram that I used. So I made this diagram. Basically, it's the same thing we did, but just in diagram form. I'll explain it. So it's basically just understanding the process better. It's more streamlined. Obviously, it's smaller, right? So we just do solve 5 at the top like we did. So because it's odd, right? It calls solve 2. Solve 2 branches to 1 and 0, like we saw in the calculation. And because 2 is even, right? And then we call solve 1. So we do 1. So 1 is odd. So 0 is the base case. Returns 1. Solve 0 returns 1 directly because the base case, right? So it's basically exactly the same thing. It's just a diagram just represents how the recursive calls and combination work step by step. It just helps us like the whole algorithm. I'll calculates like sum of 5. We can do this for every number. I just think 5 is easier. So yeah, that is pretty much my presentation, and thank you.